wanna ball with your kids.
Alright, ladies and gents, so it's time to get triggy with it. Today we're going to be evaluating trig functions. So you're definitely going to need the unit circle and table from the application in the last section, 9.2. Okay, that was your application part of the last section. So make sure you have that handy because we're going to be referencing that throughout this entire lesson today. But just in case you don't have one, you can definitely print one out or maybe look one up online somewhere to help you out with this lesson. So we're going to talk about two different things when we are evaluating trig functions. The first piece is finding exact values. So that means no decimals. Okay, we're dealing with fractions. All of these different values we have in your table are exact values. Now eventually we're going to talk about approximate values. That's when we can use decimals. So our calculator is a good handy-dandy tool for us to use to approximate values. So there's a big difference. Approximate values, we can use decimals. In other words, our calculator can help us out. But for exact values, we do not want any decimals. So I'm going to draw decimals, circle around it, and a line through it. So no decimals. So let's talk about how we can use this chart to help us find exact values. So for our first example here, we want to find the cosine of 150 degrees. What would be the exact value of this trig function at this particular angle measure? Well, we got to find two things first. We got to first look at our cosine column, which would be this guy right here. And then we want to try to find the 150 degree angle, which would be this guy right here. So just like kind of reading any other table, we're going to go across the 150 until we reach the cosine column. So it looks like our exact value is negative square root of 3 over 2. Not too bad, we're just reading a chart. If we do the same thing for cosecant, this time though we're focusing on a radian measure, so we got to find 2 pi over 3 as a radian, so that's right here. Oh, I didn't mean that. I'm going to highlight it. There we go, 2 pi over 3. And then cosecant, that's our last column, at least in this table here. So if we go across 2 pi over 3 till we get to the cosecant value, or trig function, we actually get 2 square root of 3 over 3. So exact values, no decimals. We're referencing the fractions and maybe even whole numbers in some case on our trig table. Alright, tangent. Okay, so let's focus on our tangent column. That's right here. But notice how the degree measure is negative 270, and we don't really have that, or at least on this table I don't have that here. So what I need to do is try to find the coterminal angle to this 270. So if you think about it, I'm actually going 270 degrees in the clockwise direction, but what if I were to actually go counterclockwise, the way we normally would go? So if I were to take 360 minus the 270, I would be left with 90 degrees. So we actually got to take a look at the 90 degree row here till we get to the tangent column, and it looks like it's undefined. We do not have a value for that degree measure, specifically looking at a tangent trig function. So same thing here. Notice how 405 is kind of off our chart. We got to find the coterminal angle that would make this 405 degree angle. So let's take 405 minus 360. And that gives us 45. So we're actually focusing on the 45 degree row here until we get to the sine column, happens to be first. So our trig value exactly would be square root of 2 over 2. Alright, so now we're going to transition into finding approximate values, and if you thought finding exact values was easy, okay, just using or referencing your table, these approximate values are going to be simple because we're using a calculator. So let's bust out our calculator, and we're simply going to type in the cosine of 150 degrees. So once our calculator turns on, we want to make sure that we are in degree mode, okay, because we're talking about 150 degrees. So let's go ahead and hit our mode button on our calculator. Oh my gosh, the calculator's so slow. So we are in degree mode, which checks out. So we'll hit second quit. And now we can simply type in cosine of 150 degrees. And it looks like the approximate value would be negative 0.866, we'll say. So negative 0.866. Pretty simple. Alright, now the thing is, we do not have a secant button, at least on the calculators, we use in class. So what we got to do is transform, because notice how we just have sine, cosine, and tangent, and we have the inverse trig functions. We do not have the reciprocal trig functions. So we got to rewrite secant in terms of either cosine, sine, or tangent. That way we can use our calculator. So secant is 1 over cosine, and we're specifically looking for an angle measure of 210 degrees. So let's go ahead and just write down 1 over cosine of 210, and this is exactly how we're going to use our calculator to approximate the value. 1 divided by cosine of 210 degrees. So approximately, we would get negative 1.1547, we'll say. But if you take a look at the next one, notice how we are now dealing with radians. Okay, this is no longer a degree measure. 5 pi over 6 is dealing with radians. So if we're going to use our calculator to help us approximate it, we need to make sure we are in radian mode. So go back to the mode button, and instead of selecting degree, make sure you are in radians. So we'll go ahead and hit enter there. So now radians is selected. We can hit second quit. Now, just like secant, cotangent is not one of our regular trig functions. It's a reciprocal trig function. So let's rewrite cotangent in terms of tangent. So that'd be 1 over tangent of 5 pi over 6. So let's type that into our calculator exactly how we see it. 1 divided by tangent of 5 pi. Now, pi is a little blue guy right there, kind of below your clear button. 5 pi divided by 6. And approximately, this value would be negative 1.732. There we go. Now, if you look at the last one, we're kind of back in degrees, so we got to make sure our calculator fits that example. So back to mode, and we got to go over to degree and select that. I don't know why my calculator's so slow. Kind of got a mind of its own today. All right, again, but cosecant right here is not one of our regular trig functions, so we got to write it as 1 over sine of 170 degrees. So let's go ahead and use our calculator. 1 divided by sine of 170, and we get approximately, wow, 5 point, maybe we'll say 759. Ooh, 5.759. There we go. All right, so using our calculator, approximate decimal values, really easy. But there are some useful decimals to know, because if you go back for a second and take a look at your unit circle table here, notice how all of our fractions are kind of the same representation. We either have 1/2 square root of 2 over 2, but also square root of 3 over 2. And they're kind of repeated throughout this table. Sometimes they're negative, sometimes they're positive. But these are kind of the 3 big exact value fractions that we're dealing with. So it might be useful to know what these exact values look like as decimals. So hopefully we already know that 1 divided by 2 as a decimal is just 0.5. But we can type in the square root of 3 divided by 2. And even though that's an exact value, square root of 3 over 2, the approximate value would be 0.866, we'll say. And then if we were to try the square root of 2 over 2, square root of 2, come on calculator, be my buddy. Let's see, that's about 0.707. Alright, so these are useful decimals to know, because notice how, for this guy right here, cosine of 150, even though we used our calculator, we got negative 0.866. But if you know that that decimal is actually the square root of 3 over 2, we can easily write this as an exact value. It would be negative square root of 3 over 2. And take a look at your table for a second. The cosine of 150, if we go back, cosine of 150 is negative square root of 3 over 2. So these are very useful decimals to know, especially when you're using your calculator, because if you recognize those decimals, you know what the exact value actually is. Alright, so let's go ahead and reference our unit circle chart to help us find a particular angle measure in degrees. Notice how we're talking between 0 degrees and 360 degrees for these specific exact values. So we want to figure out which angle measure or measures specifically for cosine would have an exact value of 1/2. Well, let's take a look at our cosine column, and we're trying to find exact values of 1/2. It looks like we have one here, and we don't want negative 1/2, we want positive 1/2. So let's keep going. Is there any other positive 1/2? Looks like we have that one there. So what are the angle measures that give us these exact values specifically for cosine? Well, it looks like we have an angle measure of 60 degrees, but we also have an angle measure of 300 degrees. So we actually get two cosine values, two angle measures that have those same exact values. And it kind of makes sense because if you think about the unit circle for a second, 60 degrees is somewhere up here. But if you think about the ordered pair that would show up in this quadrant, at least in terms of its sign, the cosine value is positive and so is the sine value. Now, in which other quadrant is the cosine positive? Because notice how this is a positive 1/2. Well, that would be somewhere down here, because in this quadrant, cosine is also positive, but sine is negative. And if we were to go, if our initial degree is 60 degrees up from the x-axis, the reference angle, at least for the bottom part, would be 60 degrees below the x-axis. So if we were to take 360 minus the 60 degrees below the x-axis, notice how that's giving us that 300 degree measurement. So we're possibly going to get two degree measures for all of these exact values, because we have different quadrants where either sine or cosine is both positive, maybe sine is both positive, because in this quadrant cosine's negative and sine's positive, so notice how those would have the same exact value. And down here, both of them are negative. So both cosines would have a negative value in these two quadrants. So it all comes back to this idea of what are the signs, positive or negative that is, not the trig function sign, what are the positive or negative signs of your different trig values in these quadrants. Let's check out tangent. So we're focusing on our tangent column and specifically looking for a negative square root of 3. Looks like we have that there and down here. Okay, so two more values. Looks like that's giving us 120 degrees and also 300 degrees. So again, using your unit circle table, not that bad to read it. Alright, so let's go ahead and talk about how we can find these two angle degree measures for these particular trig functions using our calculator. Because notice how in the last two we did, these were exact values. So we could use our chart to help us find those angle measures in particular, but these are not exact values. These are decimal representations. And if you really take a look at these three decimals are not any of those useful decimals we said we should probably know, like 0.5, 0.866, and 0.707. So the ones we're working with are not those nice decimals that actually are exact values. So we're going to have to use our calculator somehow to figure out what this angle is, particularly in degrees. So if we want to try to isolate this angle, we want to get the angle all by itself, we would have to move the cosine to the other side. But when we do that, we have to move it over by using the inverse, or the opposite, which would be cosine to the negative 1. So if we were to actually type this into our calculator, the inverse of cosine to this particular decimal, make sure you're in degree mode because we're talking about degrees, we would need to hit our second and then cosine, and we have 0.2079. In our angle degree measure, it looks like pretty close to 78. We'll just say 78 degrees. But the thing is, just like the other two examples we had, we ended up with two angle measures. So we need to figure out what is this other angle measure. This is when we need to think about our unit circle. So let's go ahead and draw a circle. Our first angle measure is 78 degrees. So I'm going to go ahead and draw that in. So this is 78 degrees. And in this particular quadrant, I'm going to label what the signs are of our trig functions. Cosine is positive, and so is sine. Now notice though how we're particularly focusing on cosine. So we should be focusing on this positive sign right there. So in which other quadrant is this cosine value positive? Well, maybe we'll write out the other ones. Cosine's negative over here, sine's positive. They're both negative down here. And in this quadrant, cosine's positive and sine is negative. So it looks like in the fourth quadrant, cosine is also positive. So I'm going to draw another angle that's 78 degrees below the x-axis. So our first angle is 78 degrees up. Our second angle should be, our reference angle should be 78 degrees below. So if we take 360, because that's this line right there, 360 minus 78, because we're going backwards, we would end up with an angle measure of 236 degrees. No, I'm not. I'm looking at the wrong one. 282. Get it together, Miss Bites. Alright, so the other angle measure is 282 degrees. Now, notice how you can always check your work. Let's go back to the very beginning. If we were to take cosine of 78, notice how that's approximately the decimal we started with, 0.2073, or 79, right there. Now let's check our other one. Let's do cosine of 282. We end up with the same exact decimal representation. So there is a way to check your work. Just make sure that you were falling in the right quadrant. Alright, so let's try another one. This time we're dealing with cosecant, but again, we can't really use this on our calculator because we don't have a cosecant button. So we need to turn cosecant in terms of sine, cosine, or tangent. Cosecant is the reciprocal trig function of sine. Alright, so this one we're going to have a little bit of math involved here because we want to somehow isolate this trig function. So what we can do is, let's see, we can maybe multiply the sine over. So we'd have sine of our theta, our angle. Then we can divide the negative 1.2062 over. So 1 divided by that gives us negative 0.82905. And now we just have to move the sine over. So we're going to use that inverse operation, sine to the negative 1. And that should isolate our theta. So let's go ahead and type this into our calculator exactly how we see it. We need the inverse of sine, and we had negative 0.82905. And it looks like our angle measure is negative 56. Alright, so let's write that down. We have negative 56 degrees. So, but let's think about this. If this is a negative 56, that means we're actually going down 56 degrees. We want an angle that's positive, okay, something between 0 and 360. So instead of going down 56 degrees, what would we actually be traveling if we went in the positive direction? So what we got to do is take 360 minus this 56 to actually get a positive angle measure like we're looking for up here. So if we were to take 360, maybe I'll write that out for you. 360 minus 56 degrees actually gives us an angle measure of 304. Alright, so what I'm going to do is kind of group these together. So our theta so far is equaling 304. We just got to figure out what is the other angle measure. So let's go ahead and draw our unit circle. Angle of 304 degrees is going to land somewhere in here. And in this particular quadrant, cosine is positive, sine is negative. But notice how we're focusing on sine, because sine and cosecant are those reciprocal trig functions. So in which other quadrant is sine negative? Well, that would be this guy over here. Because in this quadrant we have negative, comma, negative. So if this reference angle we said was 56, notice how it's negative 56, 56 degrees below the x-axis, then this one should be 56 degrees as well. So we got to take 180, because that's this line right here, and add 56, because we're traveling a little bit more, and that will give us our second angle measure. We get 236 degrees. So the two angles that we have are 304 and 236. Again, you can always plug them back into your sine over here, 1 divided by sine of your angle, and you should get this answer. You can always check your work. All right, let's try one more. Cotangent. Okay, we can't have cotangent, so let's write it in terms of tangent. Tangent of our angle. And it looks very similar to the one we just did over here, so maybe we'll follow the same steps. We can multiply the tangent over. Maybe divide by that 1.42, and that's going to give us 0.704225. Now in order to get the theta, the angle by itself, we have to move the tangent over, so we're going to have to use the inverse operation. Look something like that. So let's figure out what our angle degree is. So we have the inverse of tangent, and 0.704225. And this angle is, we'll say no. Oh, I forgot the decimal. That's a big, that's a big difference there. All right, inverse tangent, we need 0.704225. Notice how that's almost 90. Okay, but this one's going to be a little bit different. We have 3 or 35, maybe we'll say 0.16 degree. All right, so our angle so far is 35.15, or we said 16 degrees. All right, so now let's think about what is that other angle measure we might have. Let's go ahead and think about our unit circle. So an angle of 35.16 degrees, somewhere right here, in this quadrant, positive and positive. But notice how we're focusing on tangent, and tangent is the idea of sine over cosine. So if we were to take the sine value, which is positive, and divide it by the cosine value, which is positive, the tangent is actually positive as well. So in which other quadrant is tangent positive? Well, it's going to be over here, because in this quadrant, cosine is negative and sine is negative, and if you take a negative divided by a negative, your tangent is going to be positive. So we're actually in the third quadrant. So if this angle is 35.16, then this reference angle, remember always with the x-axis, is going to be 35.6 as well. So we got to take 180 plus 35.16 to get our second angle, which is going to be 215.16 degrees. Again, you can always check your work. Go ahead and do 1 divided by the tangent of these angles to see if you get that decimal representation. Alright, so what I want you to do is pause the video, try these on your own. I'm telling you to use a calculator, so you really don't have to use your unit circle table or chart if you don't want to. Go ahead and use a calculator to help you with these 6 examples. Alright, so let's check it out and see how we did. The first 3 I think were pretty simple for us. We could just type those into our calculator. Again, be careful what mode you should be in. All of these were degrees, so be careful with that. Hopefully those went really well. Let's go ahead and take a look at the next 3. So we're trying to isolate that theta measure, that angle measure, and we're still talking about degrees. So to move over the cosine, we need to take the inverse of that. And when you type that into your calculator, you get 148 degrees. But we got to find that other angle. So if you think about 148 degrees, that would give us an angle in standard position somewhere right here. And the reference angle to the x-axis is 32 degrees. So we want to figure out in which other quadrant is cosine negative, because that's where our first angle is located. It's an actual negative value. Notice how we're dealing with a negative number right there. So in which other quadrant is cosine negative? That would be this third quadrant. So if we were to draw another reference angle here, instead of 32 degrees above the x-axis, we're going to go 32 degrees below the x-axis. So that means we got to take this 180 plus 32, which would give us 212 degrees. That's what this angle would be right here. Again, you can check your work, plug in 212 for the cosine angle, and you should get the same decimal. Now, if we check out number 5, we're dealing with a reciprocal trig function, so we got to rewrite cosecant as 1 over sine. Doing a little algebra here, we can eventually figure out that theta is the inverse of sine of this decimal, which would give us 44.37. So if we were to graph that angle, that would be somewhere right here. And since we're focusing on sine, in this case, sine is positive. So in which other quadrant is sine positive? Well, that would be the second quadrant, right there. So let's draw another reference angle, but just in the second quadrant. Instead of being 44.37 degrees above the x-axis on the right-hand side, let's draw the same 44.37 degrees above the x-axis on the left-hand side. That way we're in this quadrant. So what we gotta do is take 180 and subtract that 44.37 because we're a little bit above it, which would give us 135.63 degrees. Again, you can always check your work, plug it back in. Now, hopefully we noticed that something was strange here going on with number 6. If you were to solve for your theta, use the inverse sine of 1.2, you probably got an undefined or not possible message. Okay, that's okay. Not all of these inverse trig functions are going to have an answer or a degree measure. And this is what's actually going on. Notice how we're specifically focusing on sine right here. And if we were to draw a right triangle, 3, 4, and 5, maybe that would work in our Pythagorean theorem. The sine in this triangle is the relationship of 3, which is the opposite side, over the hypotenuse, which is 5. Now, the hypotenuse in every right triangle should be the largest side. So when we're dealing with a sine function, we're always going to have a small number divided by a large number, which is essentially going to give us a number less than 1. If you take a small number divided by a larger number, you're going to get a value less than 1. But in this example, notice how our value is bigger than 1. This is never possible because sine is defined in this manner, the opposite side over the hypotenuse. Or in other words, a shorter side divided by the absolutely largest side in our right triangle. So whenever you're dealing with a sine of an angle that equals a value larger than 1, it's definitely going to be undefined. Okay, your calculator wasn't messing up, you're not doing anything wrong. This should be undefined right here. So good luck on the practice and the application and the mastery check, and I'll see you guys later.